Hi everyone. So let's start by understanding number systems. So as we all know, we count every single day, and the origin of this number system can be traced back to old farmers when they had to count the number of sheep in their farms, and they devised a system, a simple means to count the number of sheep as they go out and to count them as they come in. And if those two quantities were equal, they were satisfied that all their sheep have come in. So it's like, let's say if this is a sheep and this sheep goes out of the farm to graze, and there is this farmer. Okay, this is my farmer who's seeing the sheep go out and collecting a stone and keeping it with him to know that one sheep has gone out. And when another sheep goes out, say this is my second sheep, when this other sheep goes out also, he keeps a stone to account for that particular sheep. So when they come back, he throws this stone away. So one sheep has come in and second sheep has come in. So if you think about it, this is a primitive counting system in which we have only one particular symbol to represent a quantity. So generalizing this idea, we can say that the number of symbols represents the complexity of a number system. So in this case, this farmer just used one particular symbol to represent a particular number. So the complexity of the number system is really less. As the time progressed and as the human intellect increased, we started using our fingers as counting instruments, and that's how we have today the well-known decimal number system. Deci stands for 10. That's why we have 10 symbols. And let me list out all the symbols. It's from 0, 1, 2, 3 up to 9, right? So we have 9 symbols and up to 9, and we have 10 symbols. So as I said, from symbols zero, so as I said, we have 10 symbols. That's why we call our number system the decimal number system. So as I said, the farmers had only one particular symbol for counting, that is represented by a stone. So I'm calling it a base. So the farmers used base 1 number system. Since we have 9 symbols, 10 symbols, 0 to 9, we call it base 10 number system. And this is the most popular number system we use. So it's like if we have a number 123, so this LSB, or the least significant position or the least significant bit, LS, least significant position, represents a value 3 into 10 raised to 0. Right. If we think about it, the second position is 2 into 10 raised to 1. The third is like 1 into 10 raised to 2. So this is the value of the number. We think of it in base 10. So we saw that we have a number system, a decimal number system, which is like the numbers start from 1, 2, 3, 4, 5, 6, 7, 8 and 9, and we have only 10 symbols. What to do for the quantities that come after that? We select this particular symbol, that is 1, and we start putting rest of the symbols with it. 10, 11, 12, 13, 14, 15, like this. We move along the number system by replacing and iterating cyclically over our symbols, and that's how our entire number systems from negative numbers or from natural numbers start, whole numbers start. So other than our decimal system, we have few other systems we have to look into. It's like a binary number system, and this came into prominence in our life. This binary number system, binary, that means 2. So the base is 2, right? So when the base is 2, we will be having only 2 symbols. Just like when we have a decimal system, we had 10 symbols 0 to 9. In binary systems, we have 2 symbols, that is 0 and 1. And this is highly used, or this particular number system is really useful in the case of computers, because voltages can have only 2 values, that is high and low, and that this voltage levels are the bottleneck to the computational performance we have today. So if the voltages could represent 4 places, then it would have been a much better computational engine if we had more than we could represent more than 2 numbers using number systems, but we have only 2. So let's take another thing. So it's like, just like in decimal, I'm writing the binary numbers. So it's like 0, then 1, then we ran out of symbols, so I'm using 1, then 0, then 1, 1. So let me put that in a box. After that, symbols are again run out, so I will put 1 again, 0, then 1, 0, 1, and then 1, 1, 0, 1, 1, 1. Then I ran out of symbols again, so 1, then I put 3 zeros. Just like in our decimal system, numbers are repeated cyclically. So is that the only number system we have? We have something else known as hexadecimal number system. So hexadecimal means hexa is 6 and decimal means 10, that is 16 hexadecimal. So what do we do? So it's similar to up till 10 symbols, but after that we need 6 more. So what are we going to do? Let's see. 1 2 3 4 5 6 7 8 9, up till 9. It's obvious, isn't it? And after 9 we started using A, B, C, D, E and F. That's 16 simples we want to count. Up till 9 we have 10, then we have 6 up to F. So normally the question comes how to convert the systems between each other. So the next video I will be talking about converting between the systems of numbers, and you guys have to remember this, that's after 9 it comes A, and actually the decimal equivalent will be 10, isn't it? And B will be the decimal equivalent of 11, C will be 12, D will be 13, E will be 40 and F will be 15. You have to remember this, and also this one. Before I end this, just wanted to do one more thing. So 0 is 0 and its 1 is 1 and 10 is 2. So this particular number in binary represents 2 in our familiar decimal system, and 11, that's 1 1, is actually 3. You have to understand this if we have to move along computer science without any problem. And tomorrow I will be, in the next video I will be discussing how to convert between these representations. Okay, thank you.